Hi, today I'm going to explain how to calculate the average molecular weight of a polymer. Well, we know that because of the polymerization process, the molecular strings have different length, and because of that they have different molecular weight. But we want to calculate the average molecular weight of a specific polymer. So we can use different methods, like for example the number average molecular weight. So let's say, for example, we have a polymer and it has 10 molecules. Some of them are like tiny, 2 of them for example. Then we have 4 that are longer. Then 3 are even longer. And then 1 that is the longest, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 molecules. So we make a graph like this. And we say, well, there are 10 molecules. Here we are going to graph the number fraction. Here we are going to graph the molecular weight of each sample, right, of this. This is in grams per mole. So we have 10 molecules, right? So these ones that are the shortest are also the ones with less molecular weight and represent only, there are 2 of 10, so it's the 20%, right? So then we have these ones that are longer, and there's the 40%, like this. Then we have 3 of these that are longer, these are 30%, so they are like this. And then the longest that are just 1, so it's the 10%, like this. And we have like something like I can't remember the name, but we want to calculate the average molecular weight. So what we do is we use this equation. So this x sub I is the fraction of molecules in the sample, right? So we have, this is the first, the second, the third, and the fourth. Then we have m sub I, which is the molecular weight, the mean molecular weight of each sample, right? So if we wanted to calculate m sub n, so we would have to write, for example, n sub n is equal to, for example, 0.1, the first molecular weight, which could be m sub 1, right? Plus, no wait, this is 2. This is 0.4 m sub 2 plus 0.3 m sub 3 plus 0.1 m sub 4, and we would get this number. So that's one method, but there's another one. Which is similar, right? We have the weight average molecular weight. This one is similar because we can have here the polymer, but instead of counting the number of molecules, what we do is count the weight of the sample that has the molecules with a definite molecular weight, right? So let's say this have some molecular weight m sub 1 and it's 2 kilograms. Then we have m sub 2, this is 5 kilograms. Then we have m sub 3, these are 3 kilograms. Then m sub 4, these are 1 kilogram, right? So we make also a graph, which is going to be actually the exact same graph. Like we have this is the weight fraction, and this is the molecular weight, grams per mole. And we have the first one represents 20%, and the second one represents half. Then the third one represents 30%, and the last one just 10%. And we use a similar equation. Where the I is the weight fraction of the sample, right? Of a particular sample like this one. And m sub I is the mean molecular weight of the sample. Right, so we're going to take here the middle part. So we can do the same, right? So it's like this. Well, now we're going to present an example. So this example is from the book. So they tell us that we need to calculate the number average molecular weight of this particular polymer. So we make a table, right? First we make the range. The first one go from 5,000 to 10,000, like this. and this is in grams per mole, right? So, and it increases in 5,000 every time. So we calculate the mean m sub I. And then we get the number fraction we have, which is x sub I. So we have from the graph so using this equation of the number average, we just make a multiplication, right? Like this. And then we take the sum. And this is the result, right? And so we can make the same thing for the weight fraction. So it's the same table, just these values change. And here is the result.